So we're going to finish up 6.3 in Calc. And yeah, we're just practicing understanding the fundamental theorem of calculus. And it's pretty straightforward of understanding that the derivative, well, if we're working backwards with the integral, then that this must be equal to f of 1 minus f of negative 3. Because remember, this is you telling you to do the antiderivative. Well, f prime is the derivative of f. So the anti would be f. And then you plug in 1 in for x and negative 3, and you subtract. So as you look at your table, f of 1 is negative 2, and f of negative 3 is 4. So negative 2 minus 4 would give you negative 6. And we can just keep moving forward and just make sure you understand you can do each piece individually. Typically, they would put parentheses around this, though, which is kind of a mathematical habit. So as we look at this, it's the same as doing each individual piece, negative 1 to 3 of f prime of x dx plus the integral from negative 1 to 3 of f double prime of x dx. The reason why I'm doing that is to let you know you have to do each one individually, because the antiderivative of f prime is f of 3 minus f of negative 1, the upper bound minus the lower bound. We're going to add to that. Let me put giant parentheses here. Now remember, the antiderivative of the second derivative would be the first derivative, f prime of 3 minus f prime of negative 1. So I did not give myself much room, but go to your table. F of 3 would be 1, f of negative 1 would be 0, so 1 minus 0 would be 1, and f prime of 3 would be 3, f prime of negative 1 is 1, 3 minus 1 would be 2, so I got an answer of 3 there. And as usual, I'm going to check with the answer key, negative 6 and 3. There you go. So notice the notation. Sometimes we write it a little bit different, but it still works. As you look at the next one, notice that they snuck a little 3 in here. And something that we'll learn here shortly is you can just pull that 3 in front. Constants can be moved in front. So then you can just concentrate on, just think about like factoring out. Like you could do 3 f prime of x. I said that wrong. Well, let's do it that way. F prime of x from 1 to 5. But what I was trying to do is write it as 3 f prime of 5 minus 3 f prime of 1. But as I go to the answer key, you can see that he factored the 3 out. Oh, I thought he did. Apparently not. According to the answer key, though, you get 6 as your final answer. And I feel like I should explain one more time that the antiderivative of the second derivative will give you the first derivative. So yeah, you can double check in here that f prime of 5 is 2 and f prime of 1 is 0. So 3 times 2 minus 3 times 0. And you get that answer. But just to give you a heads up and where we're going with this, I mentioned that you could factor out that 3 here, f prime of 5 minus f prime of 1, which by definition, or by the fundamental theorem of calculus, would be equal to 3 times the integral from 1 to 5 of f double prime of x dx. So you're kind of getting a future lesson that these constants can just get moved in front, which is a true statement, but probably should wait until I get to that lesson before I teach that. But anyway, as we move on to number 4 here, we're looking at 1/2. The antiderivative of f prime would give us f. So we're looking at f of 3 minus, I'll leave that 1/2 in there, f of negative 3, and then plus 2. Now remember, the antiderivative of the second derivative takes us to the first derivative. So we're looking at f prime of the upper bound 3 minus 2 times f prime of the lower bound, negative 3. And if any of this is not making sense, feel free to write it down. We can look at it closer. You can ask questions in class. It's just a lot of filling in with the table. So look in the table and find f of 3, find f of negative 3, find f prime of 3, find f prime of negative 3, and yeah, you should get 1, 3, 4, and 4. And because of these 1/2s in here, oh, and he did one more thing where he split it into 2. Anyway, addition's commutative, so as long as you keep this as a negative, then we should be fine. We should still get 8.5, assuming he did the work correctly, which I'm going to trust his work. So he did it slightly different than what I did, where I do these individually like I did up here, but his work is slightly different. So double check that that's right, and we can talk about it in class. I like this because he reminds you how to find the equation of a tangent line, something we've done ages ago. So as you remember, tangent line, we need a slope and a point. Well, as a reminder, we're doing f of 3. That's the point. So go to your table that f of 3 is 1, and then f prime of 3 is 3. So that tells me that the y-coordinate's 1, and the slope would be 3. So I just care about that. So the equation of the tangent line, remember, I like to see y equals the slope, x minus the x-coordinate, and then plus the y-coordinate moved over this way. It's usually how people want to write it. And then use the equation from number 5 to evaluate f of 3.1. We'll just plug in 3.1 right there. So y equals 3. Remember, 3.1 minus 3 would be 0.1, and add 1 to it. So 0.3 plus 1 gives me 1.3. Now, how do we tell if it's an over and or under approximation? As a reminder, you look at the second derivative, and the second derivative is negative there. So since we are at a negative second derivative, since the second derivative is less than 0, that's our clue that we are concave down. If it helps, draw the picture of a concave down graph. And where the tangent line is, it's always an over approximation. So that's your reason, because it's concave down, which is based off of this statement. There's your reason that we have an over approximation. Now you should be good for the homework. But before I move on, I'll show you the answer key. Notice he just writes the y minus 1. I don't like that. I'd rather see that moved over. But you can see his explanation. It's all about the second derivative. Concave down, which implies that we have an over approximation. So feel free to pause the video at any point, see if you understand it. And yeah, should be ready with the homework. I wouldn't be afraid if you use your calculator to check your work, but there's a warning for you.